Hello everyone. Today we'll talk about automatic reference counter. What automatic reference counter does is it keeps track of whether the object you have created is still used by somebody else. If it is found that the object is no longer used by anyone, then the object will be automatically destroyed and its memory will be automatically deallocated. This is how the automatic reference counter works. Let's look at an example. Here we have a class dog, and inside the foo function we create a new dog and assign the new dog to a variable of d. Now the dog is referenced by the variable d. In other words, it is used by the variable d. So by the end of the function, the variable d goes out of the scope. Therefore, there's nobody is referencing the dog anymore, and the dog will be automatically destroyed. And if you want to destroy the dog before the function ends, you can assign d to something else. For example, I assigned it to Neil. And now the d is referencing to something else, and there's nobody is referencing the dog anymore. So the dog is destroyed here. On the other hand, if we have a global variable called dg, which is also a dog optional, and then before the dog is destroyed, we assign d to dg. Now, both d and dg are referencing to the same dog. And when d is assigned to something else and no longer referencing to the dog, but dg is still referencing to the dog. Therefore, there is still someone, which is the dg, who is still using the dog, and the dog will not be destroyed. So this is how the automatic reference counter manages the memory for you, so that you don't need to worry about memory management and memory leaks. However, there is one circumstance where memory leak still will happen, which is when you have reference cycle. Let's talk about that. Note that the dog has a property called dh, which is referencing to a doghouse, and doghouse has a property called d, which is referencing to a dog. And then in the goo function, we create a dog and then create a doghouse assigned to house. And then the dog's dh property is pointing to the house, and the house's d property is pointing to the dog. So the dog and the house is forming a kind of a cycle. The dog has something pointing to the house, and the house has something that's pointing to the dog. This has a bad consequence. By the end of the function of goo, both the dog variable and the house variable go out of the scope, and we are hoping that both the dog and the doghouse will be destroyed, but they are not. This is because the house is still used by a property of the dog, and the dog is used by the property of house. Therefore, both the house and the dog are still being used by somebody else. Therefore, neither of them will be destroyed. We have a memory leak. So, in order to prevent this kind of memory leak, we need to break this kind of reference cycle. Swift provides two kinds of solutions to solve this problem. The first one is using weak reference, and the second one is using unowned reference. Both of them working in a very similar way. Basically what they are saying is, although we are referencing to this object, when you do the automatic reference counting, don't count us as someone who is referencing to the object. In other words, you can destroy the object even though we are still referencing the object. That's why this is called weak and this one is called unowned. And now, by the end of the goo function, both dog and house variables go out of scope, and the only reference that is still referencing to the dog is house.d. But now, since the house.d is a weak reference, we don't count it as someone who is using the object. Therefore, the dog is destroyed. And when dog is destroyed, dog.dh is also out of scope, and we know house variable is already out of scope, and therefore no one is referencing the doghouse anymore, and doghouse is also destroyed. So the memory leak problem is solved. And we can achieve the same kind of effect by using the unowned reference. The difference between the weak reference and unowned reference is, number one, a weak reference can be set to nil, and it is automatically set to nil when the object it is referencing is destroyed. Unowned reference is always referencing to something that's solid. It will not reference to nil or a destroyed object. A weak reference is always an optional, and an unowned reference is always defined as a non-optional. And a weak reference must be a var because it needs to be set to nil when the object is destroyed. And an unowned reference can be a var or a constant. So these are the three differences between weak reference and unowned reference. And as a general rule, if the property can be nil, then we use weak reference, and if the property cannot be nil, then we use unowned reference. Now let's talk about automatic reference counter for closure. As we talked about before, a closure is a reference type, just like a class. So automatic reference counter also applies to closure. This is an example from the book. We have a class HTML element, and this class has a lazy property called toString. And this lazy property is a closure, and the closure takes no parameter and returns a string. What this closure does is turning this HTML element into a HTML string. And because this closure property is lazy, we can safely use self.name and self.text, because by the time this closure is accessed, this object is already constructed. However, this creates a memory leak. When we create a HTML element like this, and then assign the element to nil, hoping that this element will be destroyed, but it is not. The reason is, again, we are having a reference cycle here. The HTML element obviously has a reference to the closure, and this closure has a reference self which reference back to the HTML element. So we are having a reference cycle, which results in memory leak. In order to break this reference cycle, we need to tell the compiler that although the closure has a reference to the object, this reference is really a weak reference, not a strong reference. And we can do that by using capture list. This is the second example where we are using capture list to break the reference cycle. And this is the capture list. In the capture list, we specify that the self is an unknown reference. So now the class has a strong reference to the closure, and the closure has an unknown reference back to the class. So there's no more reference cycle. Note that the capture list must appear as the first thing in the closure. As the second example, if you need to specify the signature of the closure, then the capture list must appear before the signature. And in this example, we are using unknown reference and not a weak reference because the object self can never be nil. If the object we are referencing could be nil, we should use weak reference instead of unknown reference. Lastly, I want to make a note that automatic reference counter is only used by reference types, namely the closures and classes. That's why it's called automatic reference counter. So the value types don't have automatic reference counter. The structures and the enums don't have automatic reference counter. Thank you for watching. Feel free to download the notes from my website and practice with it. See you next time.